measures their quantity of freight and the capacity of vehicle in terms of dozens. That means 1 dozen equal to 12 bottles of 625 milliliters. It's equal to 7.5 liters. And they are using 3 type of vehicles. These are the type of vehicles, and then 5 trucks are available in type A, and 2 trucks are available in type B, and 11 trucks in C. So let's get to this important part. The Lion Company measures the quantity of the freight and the capacity of vehicle in terms of dozen. So we have to calculate the cost per dozen. So we use this formula. It says distance between Land Brewery and the particular consignment agent into freight per kilometer divided by capacity of the selected prime mover. That means the above 3 category. The freight per kilometer is fixed here. So based on that above formula, we can calculate this table. It shows that when we, as example, I take 2.17. I will explain how it can get in. These are the cost per dozens. If you send 2156 2156 dozens truck to the Abhayawardhana, you will the unit cost will be the 2.17. Likewise, it has calculated. So now simplest method in linear programming can be applied to find the optimum truck movements based on the above informations. Therefore, following variables should be introduced. That means this is the variables. Frequency of trip made to the consignment agent from the brewery per day. That if frequency 1 mean the frequency of the trucks movements to the agent 1, and likewise you will get 18 agents here, and transport cost of the agent based on frequencies made by each trucks per day. So this one cell represent a total cost for a, if we send a 2156 lorry to a agent to the agent 1, so we have to spend this much of transport cost. So likewise, we can, based on the above information, the objective function can be derived as follows. This is a bit complicated because it has 54 elements here. So this is the total cost per day, and the above objective function should be minimized subject to the constraints arise from daily demand of the agent and number of possible movements available for each type trucks. Let's go to the first constraint. It says this left side you can see the transport capacity for the transported capacity for the agent 1. That means it should be greater than the daily demand of the agent 1. That means that will help us to keep that agent without making any stuck out situation. So likewise, this is the constraint from first constraint, and likewise we can derive the second one also. Is constraint from the number of possible trips for each type of vehicle. That means the trips total trips should be less than or equal the available vehicles available possible trips of the particular type of vehicle. So this is the non-negativity constraint. So Mr. Vasanta Premarathne will continue with this point on.
So good morning to you all. Okay, thank you. Good morning to you all. So based on the so after identifying the objective function and the constraints, data were fed to the Microsoft Excel solver to find out the optimum solution in the vehicle scheduling system. And so actually now that diagram is not clear, but you can see. So here the first 1, 2, 3 columns represent the existing manual vehicle systems, and the second 2 columns represent the proposed vehicle scheduling system. And so percentages represent the demand fulfillment. You can see that when you look at the manual system, so they can fulfill only 20%. But when you use the proposed system, they can represent 103, because we have 103, as he mentioned earlier. We don't send half a truck. So therefore, sometimes we have to send a full truck. As a result, we will get 103. So then that was the situation. And this is for the month May, and this situation for the month June. And again, we have the same situation. So now units cost of transportation per day per dozen was calculated to compare the cost of proposed system with the manual system. So then the unit cost of transportation per day per dozen, that is equal to total transport cost of the day divided by the total number of total volume of transport. So then based on that one, we can calculate unit cost for the manual system and the unit cost for the proposed system. So now you can see unit cost of these two. And again, actually, you can see that unit cost for the proposed system is less than the unit cost of the manual system. And we can represent that situation in a graph. So the below one is the unit cost of proposed system, and the above one is unit cost of the manual system. So you can see that unit cost of the proposed system is less than the manual one. And this is the situation for month June. And so this is the outcome. But here you can see that sometimes you can see that unit cost of manual system is less than the unit cost of transport system. So then we have that trade-off. Actually, the situation for this one, we can explain like this. For example, if you take 20th of June, that Brewery, they have sent their trucks to only 6 agents. Basically, there are 18 agents, but they have sent only 6 agents. But based on that one, when they calculate the cost, and so that day they want to fulfill 23,689 dozens, but they have achieved only 12,320 dozens. So that means they have covered only 52%. But if you consider the island, there are 18 agents, that means they have covered only 27%. So then if you calculate the total cost, they have covered only 52, but their cost is 4.21 when we consider those 6 centers. But when we consider the proposed system, and we can cover all 6 centers, and we can fulfill 108, and the cost will be 4.01. That means we can save 0.20 per dozen. So that means if we multiply by those quantities, so we can save 5,139 for those 3 centers and so distance. And if you think about the island, and if you think about the long distance, so they can save more than 50,000 per day. So that is the situation there. So this study assists the company to reduce its carbon footprint by eliminating unnecessary truck movement. Human errors were also reduced by using this systematic way of scheduling. Outcomes of the research demonstrate that the application of the proposed module for prime mover scheduling system in Brewery Ceylon PLC increased the efficiency of outbound logistics, thereby maximizing the profit of the company. And this paper therefore brings a solution to the vehicle scheduling problem and overcomes the bottlenecks in transportation at Brewery Ceylon place, subject to the following assumptions. Actually, the last one, so we have, if there is production failure, that will affect the system, vehicle breakdown, road and weather condition, and we assume actually there are 18 trucks, but sometimes we will have less than that one, so then we have that problem also. And issues of drivers and helpers and physical shape of the product, we assume that is same, that is constant. So that is the outcome of the research. Thank you very much.